Okay, so this video is designed to help you get started with the Hedwig and Errol in-class activity. You want to start by drawing a picture of what's going on in the activity. I don't recommend using graph paper, just plain regular white paper. You want to take your protractor and you're going to start by drawing a pair of axes. Once you get your axes drawn, you want to read the directions, which tell you that, first of all, Errol, who typically gets lost, flies 5 miles at an angle of 45 degrees. So, taking your protractor, you are going to measure 45 degrees with your protractor. Then you are going to turn your protractor and you are going to measure, according to the directions, 5 centimeters to represent the 5 miles. So that is what I'm going to do now. And I am now going to label that 5 miles. And I'm going to put a 45-degree angle on here, representing how long that vector is. Now when you go to draw your second vector, it will be helpful if you will draw yourself a second set of axes for what's going to happen for the second vector. So in order to do that, I'm going to come up here and pencil, and I'm going to draw myself a second axis. Okay, so got my second axis here. All right, now this time it says that the bird flies 330 degrees. And so 330 degrees. This is 270, so you got 0, 90, 180, 270. And then I'm just gonna measure out the 330, which I know is 30 degrees south of east. So I'm gonna measure 30 degrees over here with my protractor. And then I'm gonna measure off 3 centimeters once I get everything lined up, because he's supposed to go 3 miles. Okay. All right. So that is 3 miles. And I'm gonna mark that 30 degrees. All right, so at this point, the instructions tell you that Hedwig is able to fly directly to where Errol is. So I'm gonna use a dotted line to represent Errol's flight path. I'm sorry, Hedwig's flight path over to this final location. And I'm told to approximate by measuring. So I'm gonna measure that dotted line over. It looks like it's about 6.5 centimeters. So I'm gonna call that 6.5 miles. And I'm going to measure my angle, which looks like it's maybe 17, 18 degrees. So I'm just gonna call this 18 degrees is my guess. Now at this point, they tell you to break down each of the vectors to find out exactly how far you actually, well, the owls actually flew. So you're gonna take that 5-mile vector at 45 degrees, and you're gonna break that down into your horizontal and vertical components. They call this Harry's way of doing things because it's horizontal and vertical components. So as I look at this first vector, I'm going to imagine that there is a right triangle here. And in order to find the sides for that right triangle, I am going to do 5 cosine of 45 degrees, and 5 sine also of 45 degrees. Making sure that your calculator is in degree mode, you'll get 3.5 miles for both of those. Now you're going to move to your second vector. Your second vector was the 3 miles. And my triangle is a right triangle that I'm going to draw right up here going toward the x-axis. And that's a 30-degree angle with the x-axis. So that's going to be 3 cosine 30 degrees. And that is going to be equal to 2.6. Then I've got 3 sine 30 degrees. And that is going to come out to be 1.5. Now I do have to make a sign correction because this side of the triangle is below the axis. So I'm going to make that a negative. I'm going to add those up. And this will tell me that the total distance that Hedwig flew with the dotted line is going to be 6.1, comma 2 in component form or Harry's form. Now once I've got Harry's form done, I'm going to take that and I'm going to say, okay, R equals the square root of 6.1 squared plus 2 squared. And with my calculator, that comes out to be 6.42 miles, which is pretty close to my guess of 6.5 with my protractor. And then my theta is tangent inverse of 2 over 6.1, which comes out to be 18.2 degrees with the horizon. And that again is very close to what I found when I actually measured it with my protractor. So pretty close guesses. Now, what if you're a person who really wants to do things using, not using tip to tail, but you want to use the parallelogram method? No problem. Let's give that a try for you. So again, I am going to start off by drawing myself some axes. Okay, and once again, I am going to take my protractor and I am going to measure 45 degrees. Okay, once I have the 45 degrees, I'm going to measure my 5 centimeters and draw the initial path for Errol. Okay, so I'm gonna draw that. 5 miles. And I'm gonna mark that with 45 degrees. Okay, then I'm going to, from the same spot, I'm going to measure around just like I did last time. I'm going to do the 30 degrees and I'm going to measure off 3 centimeters. For 3 miles. Okay, so I have those measured. Now it's time for me to make my parallelogram. So I'm going to pick up my pencil over here and I'm going to draw a line that is parallel to the 5 miles so that this will actually look like a parallelogram when I'm finished. And then I'm going to come over here and I'm going to draw a line that is parallel to my 30-degree side. So you need to be pretty good at spotting those parallel sides in order to be able to do this. Now, once you have your parallelogram drawn, you're going to go from the origin, where your 2 vectors met, all the way out to the outer corner of that parallelogram. And that will be the vector that Errol flew at. So let's measure it just like we did last time. Okay, as you can see, it's coming in right at 6.5. And then I'm going to measure my angle. Okay, and that looks like it's coming in right at 18 degrees. And now when you break it down, you will break this down exactly the same way that we did before. So the breakdown on this as far as the vector components is exactly the same, no difference at all. You'll think about this as being a right triangle going this direction and a right triangle going this direction. And those two right triangles will enable you to finish the problem. Make sure you use your diagram and your table to answer all the questions. And I hope that helps.